Hey guys, welcome to day 12. Congratulations on getting this far. Today we're going to be going into deeper stuff of programming. And when I mean deep stuff, I mean deep object-oriented, core stuff that's really important to programming. So get excited. We are going to be talking about inheritance in Java. And so what is inheritance? Basically it allows you to build new classes from existing classes and reuse code, which is pretty awesome. To think about inheritance in code, we can first think about inheritance in real life through traits. And so your mom has green eyes, you have green eyes. Your uncle has black hair, so you have black hair. That's kind of the route, it is in code, but less hereditary, of course. But let's just dive into the code and, open NetBeans, do our usual things. So NetBeans. And so inheritance defines the relationship between a superclass and a subclass. And we'll talk a little bit more about these later, but basically the parent, the person that has the trait originally, is like the superclass, and the child who inherits the trait is the subclass. And so parent, superclass, subclass, child. Now we'll close some of these things because I was working on other assignments, so we'll close this up. And now that those are all gone, we are going to create a new project. And so we go File, New Project, doing our usual thing. And we are going to call this Animal. We are going to create animals, and we are not putting it here where I was doing networks. We are going to put it in our little desktop because that's where everything goes that we do for 30 days of code. But of course, put it where you would like. We'll hit Finish, and we're going to create this animal project. Before we start coding, we can talk a little bit more about inheritance and how it actually relates to what we've been doing already. So everything in code besides, primitive types, ints, characters, stuff like that, basically every object that we create inherits from a subclass called object. And so if I create this object here, I can already say animal equals new animal. And we can create a little constructor here that's just public animal, open, close curly brackets, there you go. We have this new animal, and then we do animal dot, and we have all of these methods that are already available to us. We haven't done any code yet. We literally just created a class, but by creating a class, everything that is created as a class inherits from object. And so object already has these methods for it, and so when we say, okay, the parent is object, we're going to create a child called animal, it inherits all of these methods that were originally for object, but we get to use them because we're children and we can use what our parents buy/have. Traits, yes. And so what this means is that object is like the superclass of everything that we create in Java. And so object, superclass, animal, subclass, object parent, animal, child. But let's try this out with an example. We know that everything inherits from object because we get these guaranteed methods, we get these inherited things. But what if we created a superclass and then had other classes inherit from it? You can have a tree where it's object is the grandparent, but we just call it parent or superclass. So object is a superclass, and then you'll have animal, which is a subclass of object, but it might be a superclass of something called dog or cat or something, where the dog or cat inherits things from the animal, and the animal also inherits things from, object. And so it's like a little tree, a little family tree, if you will, of everything that we create. And so to create a superclass, we are going to implement some code. And so I'm just going to get rid of this stuff by commenting it out here. We'll just take that guy away. Take him away. Alrighty, so the first thing we're going to do is in our constructor, we're just going to add a little print statement. It's going to say system.out.println, an animal has been created. And so when we create a subclass, which is our dog, so animal's the parent, dog is the child, it will say an animal's been created, and then it'll say, if we in our dog class print something out that's a dog has been created, it'll say both a dog has been created and an animal has been created because a dog is an animal. And then we're going to add a method. Going down here, we'll do public eat because we like to eat. And then we'll do open close parentheses, and we're just doing print statements here. A lot of this is going to be print statements just so we can see the relationships between the superclass, subclass, parent, child, and how we can mess with that to actually reuse, do cool things with our code. So what are we even printing out? I don't know. We are printing an animal is eating because, when we eat, an animal is eating, and our return type is going to be void. we eat, we're hungry. Okay, continuing on. We are going to create another class. I know double classes, here we go. So we'll go to animal here, we'll do control click, new, Java class all ready for us, and we are just going to call this dog. It's going to be in our side of our animal package, all good to go. And so we delete these things. I will change this. That will be my goal for the end of the 30 days of code. On the last day, I will change it so the comments don't show up. Okay, so here in our dog class, we want to say our animal is like the parent of our dog, but that relationship isn't automatic. Our dog automatically is a subclass or a child of object because, that's just in the background of Java, but it's not related to our animal yet. And so with this tree here, as you can see, we have object at the top and then animal and dog both are subclasses of object. But what if we can make the relationship object, animal, then dog? To do this, we have to add extends animal. And so it's extending that class, it's inheriting from that class. This is how we do it with the code. So what does this mean? We can add a constructor. And it's going to be like any other constructor. We'll do public dog, open close parentheses, open close curly bracket, and inside we are going to print out system.out.println, a dog has been created. There we go. But there's some things we have to do first. Before we can print this out, we need to set up our animal first. Basically what that means is that whenever we construct a dog, we also construct an animal. So we need to call the animal's constructor first. But you can't just go like animal, but then like not say, like what does that mean? Well, we have to do something called super. This is going to be a little bit confusing at first, but basically what it means is that whenever we create, a dog, something that extends something else that's not an object, it doesn't extend object, it extends something else. But that thing also extends object, so it's like, objects always related in here. We have to call super. So there we go, super with our open close paren, semicolon, there we go. And so this super is referencing this constructor. So we don't call it animal open close parentheses, we call it super because it's our super class that we're calling the constructor of. And say animal had like a parameter here, say we had int, age. Then in here, it's going to error because we need to put an age in here. So we could say 15. Our dog is going to be age 15. And that's how we pass stuff to our animals to say animal has separate properties than our dog. Like our animal might have an age, but our dog might have other properties like the thickness of the hair because, dogs can have thick or thin hair, whereas not all animals may have hair, and so that might be something specific to the dog. And so here we have 15, and there we go, and then we could have like an int age here. We could have public int age, there we go. And that would be our age, and then we could set it in here with this dot age equals age. And we'll just say all dogs are 15. But if we wanted to make this custom as well, we could add int age, put age in here, and there you go. But we are going to make it 15 because all dogs will be 15 years old when they, are created. And we're going to add some other methods. We are going to add public rough, open close paren, open close curly brackets. This will not return anything. Rough is, talking, rough. And so we are going to print out system.out.println. The dog says rough. There we go. And we're going to add like another method here, public void run, open close paren, open close curly bracket. And we're going to say again system.out.println, open close parentheses, double quote, and inside of here we're going to say a dog is running because a dog is running when we call the method run on a dog. And before we mess with some stuff, we are going to create one more class. It's going to be very similar to our dog class, except it's going to be a cat. So we'll do a new Java class here. We're going to call it cat because a cat is also an animal. Here we go, delete some of the stuff. And inside here, we are going to first extend animal because we are extending animal and we need to have an S here or else it's not going to recognize it's a keyword. Then we're going to have a little constructor here. We're going to say public cat, open close parentheses. Inside the parentheses, we're going to put an int age because, animals have an age. All animals do. And so then we're going to call our superclass with super open close parentheses with our age inside so we can set the age of our animal. Then we're going to write system.out.println and say a cat has been created. There we go, semicolon. And a cat has been created, and inside of our animal class, we have set the age to whatever age the user puts in. But, you know, cats have 7 lives, so we'll say it's 7 years old, and we won't have that parameter. But if you want to have that functionality, it's there. There you go. Then we're going to add 2 methods. We're going to add a meow and a prance method. So we'll do public void meow, because cats meow. And then we're going to have a public void prance, because I imagine cats prancing. I don't have pets, but you know, I've visited people. They have pets, they prance. Yes, okay. System.out.println, and we are going to say a cat meows. And then we are going to say in our prance, system.out.println, a cat is prancing, and we should spell cat right up here, semicolon here, and there we go. Now, how does this all fit together? Well, if we go back to our animal, we can run a bunch of stuff in our main function, and you'll kind of see how it fits together. So we will actually uncomment this line of code here, and we'll change our animal to A, and we'll put an age in here that's, I don't know, 5. Because animals are 5, or this animal will be 5 years old. And then we are going to create a dog D, which will be a new dog, and we already set the age to 15, I believe it was. Yeah, 15, so we don't have to worry about implementing the age, whereas we did when we implemented like a direct animal. Then we're going to just add a bunch of code here. We're going to do cat C equals new cat. We're going to do d.rough, open close parentheses. We're going to do c.meow, open close parentheses. We're going to do a.eat, open close parentheses. We're going to do d.eat, open close parentheses. We're going to do c.eat, open close parentheses. We're going to do d.run, open close parentheses. And then we're going to do c.prance, open close parentheses, and semicolons on all of those. And so let's just see what happens here. We'll press play. It'll run. And we have a lot of print statements. Pulling this up here, we are going to scroll up, and it says an animal has been created. Well, that was our animal A. Then it says again, an animal has been created, because D is in fact an animal, and we call that constructor for animal, which prints out an animal has been created inside of our dog by saying super. Then we go back down here, we say a dog has been created, obviously because we created a dog. Then it says an animal has been created again because we created our cat, and after that a cat has been created because cat, as you can see here, calls our super, which prints out an animal has been created and then prints out a cat has been created. Going back to our main, we do d.rough. It says the dog says rough. c.meow, obviously the cat meows. And then we can actually do a.eat, d.eat, c.eat, because they're all animals and they all have access to this function eat, because dog and cat extend animal, so they have access to all the methods, you know, animal has. And so they can eat just like animals because they are in fact animals. They're part of the animal family here. So here we have an animal's eating, an animal's eating, an animal's eating, because the animal, dog, and cat, they're all able to eat. We scroll down a little more here in our console, and we have d.run, a dog is running, c.prance, a cat is prancing. Does this kind of make sense? Basically, we have our animal, which is like our parent, our superclass, and it has methods, and then it has children, our dog and cat, which have access to those methods but don't have to use them. They have them as options. They can eat, or they can have their own specific methods, rough and meow, where a dog can only rough and a cat can only meow. A cat can't rough because it's only in the dog class. They don't share that. But however, they can both eat because they are both animals, but a dog is not a cat is not a dog, but dog and the cat, both animals. Okay, there we go. Superclass, subclass, there we go. But what happens if we do something like this? If we go back to our main here, we can add a little, thing. What happens if ... What if we do animal O equals new dog? The compiler won't complain because a dog is in fact an animal. However, O is not going to have access to the methods of the dog because the compiler thinks it's an animal. So you can do O.age, O.eat, but you're not going to have access to our dog, rough or run. So we can generalize with our constructors. We can have a constructor be super specific, but if it's an animal inheritance, we can step back from that. But we can't say like new animal is a dog. Like if I try to switch this, dog, new animal, and then we add like 3 here, it'll complain because they're incompatible types. An animal can't be converted to a dog, but a dog is in fact an animal, so it can be converted like down to an animal. kind of makes sense. So a subclass can be generalized to its superclass, but a superclass cannot be like specified down to a subclass because it can't be initialized like that. So we can generalize, but we can't get more specific once we use the new operator. So we will comment this out and have that little note there. And now we can actually try to access our age, properties. And so if we try to do d.age, we can actually print this out to the console. So if we do system.out.println, if we spell things correctly, .out.println, we can print the dog's age to the console, even though the age is part of the animal, the superclass. We can still, as children, access, things that our parents have. And so d.age, that'll be 15, and then we have our cat, which is 7. So then we can do that after like our meow, c.age, and we can print this out, run it, there we go, dog's 15, 7 is cat, so we have access to the stuff. But we can make it so we do not have access, so that age is only, inside of our animal class and it can't escape that. And so how do we do this? Well, if we go back up here, right now our age variable is public and we want to make it private because we only want the age to be accessed inside the animal class. If we do that, this would be a case where I can't do d.age because it has private access in animal. This is a little bit about how I was talking about how we kind of just ignored the idea of public and private because we weren't working with like multiple classes yet, but now we are, so we have to worry about that type of stuff. And so if we didn't want like dogs accessing things that were an animal, that would be the way to do it. So we will actually make this public again so we can print things out to the console and it will be nice, but I will put this in a comment up here and we will say like public age versus public.age, and we need this to be private to make sense in our comments. Yes. But what if we want to make this like private, but we also want to be able to print it out here? Is there a best of both worlds situation? Well, kind of. We can do a getter. See, they're coming in handy now. We can do public int get age, open close parentheses, open close curly bracket. We can say return age. And then here, we do that semicolon. Instead of saying d.age, we'd have to do d.getAge. And it would actually allow us to do that because the method is public. But if I change this method to private, no one can access the age either way. And so why would you do this? Why would you have like a private variable and then a public, method accessing that private variable? Well, like I was saying in the last video, you can have one way in, one way out methods, and this is what that does. It gives you kind of a control on who can access the age, and like if you have a huge problem with something changing the age, get age or set age or something, those would be the methods to look at if something weird is happening with your age variable. So that's it for this video. It was quite a short one, keeping it concise. And so what did we learn? We learned about inheritance. In inheritance, we have a superclass and we have a subclass. Object is a superclass of every single thing we create in Java. It was a superclass of our library catalog. It was a superclass, of our arrays, of everything out there that we created that was an object, of our cats, our dogs, our animals. It was the superclass, and everything that we created in Java was a subclass. What we created today, we had our animal, which was a subclass of object, but a superclass of our dog and cat. And basically what that meant is that in our dog and cat classes, we didn't have to implement an eat function. We could just call animal.eat and, our animal would eat. We didn't have to like put this method and copy it in both the dog and the cat classes. It was just, available for us because they both extended animal. Hence the reusability of code when you use inheritance, extensions, and subclassing, superclassing, etc. So as the subclass, our dog and cat each had separate methods, and they could potentially have separate variables, but we just didn't implement it here. They each had their separate speak function, and they each had their separate run function, but they both had access to the same eat function in animal because they both extended animal. Inside of our constructors, we did something that was called super, and that basically accessed our animal constructor and allowed us to set up our animal that was inside of our dog kind of, and then set up our dog afterwards. And I think that's it. We went down here inside of our main function and we did this thing where we did a what if, and we saw how we could generalize, if we have a dog and we create a new dog, we could put animal on the other side and it would allow us to do it, but the vice versa wouldn't work because you can generalize to an animal from a dog, but you can't go from an animal to a dog. You can't get more specific. You can't go from a superclass to a subclass, but you can go from a subclass to a superclass because you're generalizing. And so that's it for this video. The HackerRank challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.